In the last session, we have completed problem number 5 on estimation. In this session, we shall learn the testing of hypothesis. Already this testing of hypothesis in the earlier sessions we have learned. But let's see what is all this again. Testing of hypothesis deals with what? The verification of validity of presumption regarding the population parameter. So, testing of hypothesis is nothing but verifying the validity of the statement. What statements, how to verify that is what we have to learn. For time being, just remember, testing of hypothesis is nothing but verifying the validity of the statement, right? Then to verify that, we require two further hypotheses. One is called as null hypothesis, another is called as alternative hypothesis. Very important part. Null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true. What is null hypothesis? It is nothing but the hypothesis which is tested for possible rejection under the assumption that it is true. So whenever we see a statement of a company or the statement of an experiment, null hypothesis we should write in such a way that it gives you a positive answer. Positive answer means what? Null hypothesis should be always equal to, say for example, we have to test in the problem whether births to male and female children are equiprobable. What should we test? Birth to male and female children are equiprobable. Then we should say null hypothesis, they are equiprobable. We cannot write that they are not equiprobable. Suppose if it is asked, height of class A students is more than class B students. I repeat, we have to test that heights of class A students is more than that of class B students. So we cannot write the null hypothesis using the words not equal to, more than or less than. Null hypothesis should be always equal to. So the null hypothesis will be height of class A and class B students are equal. I repeat, null hypothesis should be always equal to. It cannot be more than, less than or not equal to. Those words are not used in null hypothesis. Alternative hypothesis. It is the hypothesis which is accepted when null hypothesis is rejected. So when your null hypothesis is rejected, then the alternative is accepted. The only question arises how this is to be written, and that is very important what we are going to learn in this session. Null hypothesis we denote by H0, alternative we denote by H1. We'll take a simple example. If you want to test whether the population mean is 50, this is what we have to test. What? Population mean is 50. Let's see first what null hypothesis we should write. Null hypothesis means H0. What will write H0? Population mean. Population mean is 50. That means your mu is always equal to mu naught. Your mu is always equal to mu naught. Now the question is, what will be H1? H1 we can write in three types. Like, first it may be not equal to, it may be more than, or it may be less than. That depends upon the problem. Like for example, say what H1 can be. What H1 can be? It can be population mean is not equal to 50. Here we say that mu is not equal to mu naught. Population mean, other way of writing your alternative hypothesis. Population mean, say, is more than 50. More than 50 means your mu is more than 50, or say mu naught. One more way, population mean is less than 50. Is less than 50. So mu is less than mu naught. This is what one should remember. When you write null hypothesis, always it has to be equal to. Then the question is H1, which one we should write? The one which we like? Now, the one that is mentioned in the problem. If they have asked to test something which is more than, then only your H1 should be more than. If they have asked to test something which is less than, then only H1 should be less than. In case, if they have asked like this, population mean is 50, have they used the word more than 50, less than 50? No. In that case, your H1 should be not equal to 50. More than, less than words in H1 are only to be used if the problem specifies. If they have asked to test that, like population mean is more than 50 is what we should test. What you should test? Population mean is more than 50. Your H0 will be same. Population mean is 50. H1 will be this because they have asked to test more than 50. If they have asked population mean is less than 50, H0 will be same. H0 should be always equal to H1 will be less than 50. But here they not mention more than nor less than. So in this case, this is going to be the H1. Population mean is not equal to 50. So it's very simple to remember. Remember that whenever we have to test anything, null hypothesis should be always equal to. When you write null hypothesis, not equal to, more than, less than cannot be used in it. It can be used in H1. When to use? It depends upon the problem. Once you write H0, H1, when you solve the test statistics, you will get an answer. When you solve the test statistics, you will get an answer. Then the question is how to verify that. Because testing of hypothesis is not only solving the formula. It says verification of validity of the presumption. So whatever is this statement, we have to test it for the possible rejection. How to do that? A simple concept here. First, to start the test, see, we need to see what is the test. Is it either a two-tailed or one-tailed? Then the critical region, the critical values, and then how H0 is accepted or rejected. To find out that, the beast lies with H1. See what is H1. Is it not equal to? Is it more than? Is it less than? We'll see step by step. Say for example, in the first case, it is not equal to. H1 is not equal to. When H1 is not equal to, remember that the test is always two-tailed. Two-tailed means on the normal curve we shade both the tails. The upper tail with plus infinity, the minus infinity with as the lower tail. Here, the two-tail test. See here, the two tails. What is all that we will say? Critical region has to be the upper and the lower tail. Upper tail as well as the lower tail, the critical region. Critical region means what? Critical region is nothing but the rejection region. Critical region means the region that rejects the null hypothesis. I repeat, what is critical region? It is nothing but the area, the region that rejects the null hypothesis. Like for example, see here the two-tailed test. This is the rejection region, two-tailed, upper tail and the lower tail. We shed the rejection region. What region we shed? Rejection region. Then we have got the answer already of the test statistics. If that answer, what we have solved by using the formula, lies in between the shaded area, lies over here, either in this part or in this part, in the rejection region, we say that H0 is rejected and H1 will be accepted. H1C, it's here, hypothesis which is accepted when null hypothesis is rejected. So we test the null hypothesis. If null hypothesis is accepted, H1 will be rejected. If null hypothesis is rejected, H1 has to be accepted. So here, if the answer that you find lies either in this part, the rejection region, H0 is rejected. If the answer lies in this unshaded part, AR is called as acceptance region. Acceptance region means the region which accepts your null hypothesis. If the answer lies here, your null hypothesis will be accepted. Critical values, fixed. K divided by 2 because it's two-tailed. We want two values. Which two values? Plus and minus. Now if you see the tables at the level of LOS means level of significance at 5 or 1%, that's going to be 1.96. Since it's two-tailed, what we want is once plus, once minus. These values are going to be fixed. So every time there is no need to check out the table. You can remember this. If it is 1%, these are going to be the critical values. Now, What is this? This is what we have seen when mu is not equal to mu naught. The basic to remember, it's a two-tail test with the lower and the upper tail. Right? If it is more than now, more than, always call for upper tail. It's a one-tail test and there are two upper tails here. More than, one tail, upper tail. Upper tail means share the upper tail. Plus infinity is the upper tail. Huh? Lower tail is the minus infinity. So when you share the upper tail from this critical area, we say 1.645 is this part. From that we shared. If your answer lies in this rejection region, H0 will be rejected. If your answer lies somewhere here, H0 will be accepted. This is how we accept and reject the null hypothesis. The third case, or the third case, the third alternative, when mu is less than mu naught, again it's a one-tail test but not upper tail, it has to be a lower tail. Lower tail, we shade the lower tail. And the critical values are here. If your answer lies in the rejection region, your H0 will be rejected. If it lies in the unshaded part, acceptance region, H0 will be accepted. So it's very simple. How to start the verification is all based on this H1 what you write. So if you go wrong in writing H0 and H1, the whole thing goes wrong. I repeat, if H1 is not equal to, remember it's a two-tail test. If H1 is not equal to, it's a two-tail test, upper and the lower tail. The area that we shared, if the answer lies in that, rejected your null hypothesis. If it is more than, upper tail. If it is less than, lower tail. This is what one should remember. How to solve the things and get the answers we'll say. Fine? So this is what is testing of hypothesis, the basic of the next what we are going to learn now. So actually what we are learning is chapter number 6, statistical inferences. In that part A, estimation and testing of hypothesis, what we have completed in this session. In the next session, we will start with very important part B of this chapter, that is large sample tests. Thank you.